piecewise defined functions. In this lesson, we're going to learn how to read piecewise defined functions given by formulas, piecewise defined functions given by graphs, and also we learn to graph piecewise defined functions. Now you can see here, this is an example of a piecewise defined function. This function has three pieces or three different rules at different part of the domain of this function. Now f of x is equal to x squared plus 1 if x is in this interval, and f of x equal to 3 if x equal to 2, and f of x is equal to negative x plus 3 if x is greater than 2. So let's read this function that we have right now. So first thing, we need to find f of 0. So before I read this one, let me explain over here. So here in this interval, when x is from -1 up to 2, in this interval, the rule is this one. At exactly 2, the rule is 4. When x is greater than 2, that means after 2, and the rule is that this one. Now we want f of 0. We have to find f of 0. 0 means x equal to 0. The x0 belongs to this part or this interval. So therefore we need to use this rule. So we get 0 squared plus 1, so which is actually equal to 1. And part B, we want to find f of 2. F of 2, where x equal to 2. So at x equal to 2, we use this rule, f of x equal to 4. So therefore the answer is clearly 4. Part C, we want to find f of 3. So when x equal to 3, the 3 belongs to this interval where x is greater than 2. The 3 is somewhere over here. So 3 belongs to this interval. So we're going to use this rule. So f of 3 is -3 plus 3, which is equal to 0. Now find the domain of the function. Domain means all x values of the function where there is a y value. So the domain is all these x values. So already I graph over here, you can see it goes from -1 to, so at 2 exactly this one. So it goes from -1 to infinity. For any x value from -1 to infinity, you can find a y value using this function. So therefore domain is, you can write as interval inequality x is greater than equal to -1 and less than infinity, or you could use the interval notation. It is mean -1 to infinity. Now the part E, they ask you to graph the function. Now so we need to graph three parts of these functions. So if you look at each part, f of x equal to x squared plus 1, we know x squared plus 1, we know it's a graph like that, parabola open upward. So it's a curve. So we need at least 3 points to graph a curve. So the strategy is to use these endpoints as the points that we're going to use. So here, so let's make a table of values for here. For this one, I have x, and the y value is equal to x squared plus 1 in this interval. So we're going to use these two endpoints, -1 and 2, and also we need one more point at least. So the 0 is in between that, so I'm going to use that too. So when x equal to -1, in this formula I get -1 squared plus 1, which gives me -1 squared plus 1, or which is clearly 2. And then at 0, we already found it, which is equal to 1. And for this function, even though 2 is not belongs to this, we are going to use this one to just to find this point. So when 2 comes, we get actually it will reach 5. But that point does not belongs when x equal to 2. This is not the point. So in the graph, we need to make a hole. So now let's we graph it. When x equal to -1, at -1, we have the y value is equal to 2. When x equal to 0, y value is equal to 1. So we have this one and this one. And when x equal to 2, when x is 2, value is 5. 1, 2, 3, 4, 5. And this one. But that point does not belongs to it. So that is how it looks like then. Connecting these points. So that is this part. Now when x equals to 2, the value is equal to 4, which is very easy. At x equal to 2, with the value is this one, which is 4. So we have this dot, colored. And the last part, we have f of x equal to -x plus 3, which is y equal to -x plus 3, which is a straight line with a slope of -1. So what we need is 2 points. So therefore, let us make a table of values for x and y equal to -x plus 3. So we are going to have, we use 2 points. So the boundary is 2 here. So we have to use that one and one more about 2. So it's about 2. So let's see 3. So when x equals to 2, what we get? -2 plus 3, which is actually equal to 1. When x equal to 3, I get -3 plus 3, which is actually we already found that one, which is 0 here. So we got that part. So we can draw. So we can mark those 2 points. When x equal to 2, the value equal to 1 over here. Again, 2, this 2 does not belong here. It is greater than 2. So that's what we get a hole over here in this graph. And then when x equal to 3, which is 0, so it goes down, and that has to be a straight line for all the way. So you need to draw like this. So we did the graph, the function, and the last part, use the graph to find the range of the function. Range is the y value. Now you can see here in this graph, the maximum y value actually it's go up to 5, but it does not include 5. So and then it go all the way down to -infinity. So the range for the y value is go from -infinity to up to 5, and it cannot reach 5. Or if you write in the interval notation, you can write -infinity to 5, both open. Here is an example of a piecewise defined function given by a graph. Now you can see in this graph there are 3 pieces. From x equals to -5 up to 1, we have the straight line piece. And then from 1 to 5, we have this curve piece. And then from 5 to 7, again we have a straight line piece. Now f of 1 means x value is 1, so we need to know what the y value at x equals to 1. Now x1 is over here. At that time, this is the place of the graph, but you see there is a hole in the graph, and there's no any other point, colored point in this vertical line x equals to 1, mean f of 1 is not defined. It is not defined at x equals to 1. Now f of 5, when x equals to 5, so you can see there are 2 points. So this point is colored and there is a hole in this graph. That means for 5, this is the point that it belongs to x equals to 5. So which is value is 2. which is y value is 2. This point is 5 comma 2, so therefore you get this one is 2. Now f of negative 5, when x equals to negative 5, this is the point, so that is actually negative 2. And f of 7, when x equals to 7, and this is the point, and this is y value is at equal to 1. Also, suppose we want to find the domain and the range of this function. Now domain is all the x value of this function where there is a y value. Now you can see when x is from negative 5 through up to x equals to 1, there is a y value over here. And then at 1 there is no y value. So we get domain from negative 5 up to 1. And then at 1 there is no y value. From 1 to 5 there is a y value. And also from 5 to 7 also there is y value. So again that will go from this one. So it goes from 1 to 7. So the domain is from negative 5 to 1 union 1 to 7. So it is keep 1. And the range is the all possible y values in these functions. So you can see the minimum y value you can take is negative 2. So it will take from y is greater than or equal to negative 2. You can see it goes up to 2. You can take any value. And then you can take up to even 4. 4 is not included. So it's less than 4. Now, so if you write in a interval notation, that means this is from negative 2 to 4, and 2 is included and 4 is not included.